Good morning, everyone. And as you can see from my slide, from the first slide, I will be talking about IdleUp, an ecosystem to develop, execute, and share scientific workflows. So since I will be talking about platform, there are two ways to do the presentation. One would be to show video, which is, of course, very nice and probably always work. But I will try to take another approach. I will actually show you the real demo. So you will see how IdleUp works, so what you can do there. You'll see, you'll get an overview, what things are present. And this will probably make it a bit more interactive, because you can stop me at some point if you want, ask me what I'm actually doing here. And if you need any clarification, please feel free to stop me at any point you want. So a little bit of outline. So I will start with motivation. Why do we need IdleUp? What is it doing? And then about intended user database. Then I will show some demonstration on IdleUp interface. Then I will show examples of daily scientific work with IdleUp. And I will finish with future plans and conclusion. So a little bit about motivation. One of the important things in the science is actually to transfer your knowledge. So if you develop a schema or a method, you might want to share your method with somebody else. But of course, you need to know how to program, or you maybe need to write a code that will embed your scientific knowledge in these things. And then sometimes it's quite hard. Another thing that you want to do is to provide your data to somebody else. And the way you do it, you make a PDF report via email, you give a presentation. Let's take a very simple example. We have a group that like simulation group that interact with experimentalists. So, of course, the idea would be that you need to report the data, the simulation you've done. And of course, you need to speak the same language. You need to spend time to prepare your data, prepare your presentation, and send it to them. So what we envision with IdleUp is a more straightforward way and more direct way to provide your data to the people who actually need them. Moreover, the experimentalists who never done the calculation, they can actually use IdleUp to run the calculation, even though they don't know how it exactly works in the background. So what is the user database of all infrastructure that we provide? First is AiiDA. Of course, you already know about AiiDA, and you know that it requires quite some knowledge of Python, Unix, and Bash. Knowing that, you can write high throughput calculation, you can make high throughput calculation, you can write complex workflows, and you can develop AiiDA plugins. But what about people who actually doesn't know how to program, but they still want to use the results of your research? They want to use your know-how. For them, we provide IdleUp, which is designed for people who doesn't know Unix, Bash, and Python. It can run predefined workflows that you have developed, and it also helps you to analyze the results. And of course, there is a last thing that we provide is called Quantum Mobile, which is a virtual machine that has AiiDA and AiiDA and IdleUp installed. And you actually were using this during the tutorial. So the virtual machine that you were logging into was actually Quantum Mobile. Now, so where do we stand in this schema? So we have AiiDA, which is quite a powerful tool. It can run complex workflows. It stores the computer data most often locally, but of course, as you heard from the previous talks, it can be also done in some remote server. Then it stores the data provenance, which is important, so you know where your data are coming from. And it also has Python command line interface. And AiiDA is able to directly interact with the supercomputer. While IdleUp, in turn, is something that is designed to interact with AiiDA and with the user, It is tightly integrated with AiiDA. It provides user-friendly interface through Jupyter notebooks and widgets. It allows for easy application development, so you can write a web browser application without knowing JavaScript, which is quite nice. You only need to know Python. And this is all of this is thanks to Jupyter and App Mode enabled. App Mode is basically the kind of an application that will hide all the source code of your notebook, and will only leave you with the output of this, of the execution of the cells. And of course, it has App Store for sharing your application with the community. So if you have developed an application, you can make a pull request to our App Store and to our IdleUp registry, and your application will appear on the App Store. Now, this is the time already to introduce IdleUp. IdleUp. The two key things that you will see once you log in into IdleUp is the home application, which has a file manager that allows you to browse files, as Linux terminal. It has a task manager that will allow you to kill like zombie tasks or something that you can actually manage your tasks and see what you need and what you don't need. You can just close them. Then you have App Store, which allows you to install, update, and uninstall applications. And it has some help button that you can click on, and then you will be redirected to some wiki page which tells you and explains you how to use IdleUp. And then you have a standard IdleUp application which looks as follows. You have some name, you have notebooks that every notebook is a kind of task specific. So you have, for example, graph browser. I mean, you can make it for yourself. For example, if you do a band structure calculation, you can have one notebook that will do the calculation and one notebook that will analyze the results of those calculations. And then you have like update information. If you have an update, you will see that there's latest. So if you have an update, this will become yellow and will say that there is an update available. You have up and down arrows, and you have install and install and update available to the manage app button. So now let's log in into IdleUp and see how these things work. Can you see what is happening there? So okay, so as I said, you have a number of things on the home application, which is on top. You have file manager, terminal, task, and app store. So let's just open everything. New tab. And then we go one by one and see what is there. Okay, so basically the file manager is a file manager that allows you to upload or download the data from and to IdleUp. So if you have, I don't know, a structure that you want to upload, or you have generated a AiiDA graph and you want to get it on your laptop, you can do it. You can do it through this file manager. If you would like to have terminal, that you can also have. This is standard Linux terminal which runs in the browser, so you can have access to the standard Linux commands. Then you have process manager, so it's called a task manager. Here you see that everything that I just opened, like one terminal, a calculation example, home application, and app store. And you see the app store, which is basically app store that provide you access to all the applications that are currently available on IdleUp. So if you want to, you can go select your application that you're interested in and then install it, but this we'll do later. But what is interesting for us now is actually to run the calculation. So any person who gets an account on IdleUp will have a number of apps installed by default. So here we provide a calculation example app that basically allows you to run quantum espresso workflows that Sebastian have developed in a browser. So if we click on the button, then we will be redirected to this quantum espresso example application. And what it provides to you, first of all, it provides you a way to upload a structure from one side, from your computer if you want. So you have a silicon oxide here. If you want, you can query COD database. It takes like 2 seconds or 5 seconds. Oh. It's done. We have 9 structures, so you can select the structure here, and then, or you can also have a possibility to provide example. And all of this is configurable, of course. So we will take silicon, and then we'll click on, so we can choose computer where we want to run on. We can select the number of nodes we want to run on, and the type of calculation, pseudo-potential family, a set of k-points, and then we click on submit button, and then it will get submitted. So we'll not wait until it's done, because it will take, again, quite some time. What we'll do instead, we'll go through the calculation that I already run. So here there was a set of calculations. So first I did SCF to just get an energy. And once it is done, you'll get access to all output files that Quantum Espresso has produced. You can select them here in this form. And you can also download it if you want to. So then you open it on your computer, and they are present. So this is just a standard output, Quantum Espresso output file. And then you can do a relaxation if you want to. And once you've provided an output structure, the notebook will automatically detect that and will provide also a structure here, which is the output structure of your simulation. This is the optimized structure. You can select the format you want to get it. And then you click on the download button, and then you will see the C file of the structure. And of course, you can do band structure calculation. So all of this is provided for you basically for free. You don't have to do anything. You just install, get an IdleUp account, and you'll get all of this for free. Now let's come back to the presentation. So this was a video that I kind of showed to you.
Can I stop you for a minute?
Sure. Oop, I almost destroyed the mic.
Do you have the full functionality of Quantum Espresso there?
Well, let's put it this way. We have full functionality through the AiiDA plugin, but the workflows are typically task-specific. So if you want to do band structure calculation, we have a band structure workflow that does it for you. But of course, you can enable, it's quite easy to provide a web interface to any workflow you want to do. And moreover, today, on the today afternoon session, we will be teaching how to actually make a web interface to the workflows. So you can attend it.
So not all the applications are off the shelf.
Yeah, so
you want to do GW, for instance.
Yeah, so first you need to, there's a kind of a couple of steps. You first need to get a plugin. If it's there, then you don't need to do it. Then you write a workflow that will compute, that will do GW calculation. And then you will provide, you need to write a IdleUp application for that. So those are the steps. Okay, yeah, so we have a little bit more to show. Of course, you know that AiiDA is actually designed not only to do the calculation on the, Of course, AiiDA can also do the calculation on the computer, not only on the local host computer. But if you want to, you can set up a new computer, for example, PITSDIEN that we have in Switzerland. And then you could just select PITSDIEN instead of local computer. And then the calculation will be run on PITSDIEN. So here again, I will show a quick demonstration how to set up a new computer, how to set up a new code. And if you have any question, again, please stop me anytime. I'm happy to answer them. So now we go again to this app example. And what we'll do now, okay, then we'll switch on back. Anyway, so it will be the same. So we'll have this, this part where you select the code you want to run on. If you would like to set up a new code, you can just click on this link. And then, yeah, here we go. So here you have a list of parameters that you typically input to AiiDA. You provide like a code label. You provide a computer where you want to run your calculation, and then you provide a code plugin. So all these things are kind of already predefined for you. You can just select them. And if you realize that the computer you want to run on is not present, you can click on another link, which is set up a new computer, and then you'll be redirected to computer setup notebook. Here you will not set up a password-free access because I already done it before. We'll just select the computer. For example, we take DENAP. We put the name here. We have description. We will leave it empty. Then we provide srun here, srun, and then all the rest is fine.
Yes, here.
Right. We click on setup computer, and then AiiDA will set up DENAP computer for you. And then we click on test computer, and then it will be tested. So you see that all tests pass successfully. Now we come back to setup code, and you see that this computer is still not available. We click on the refresh button, and then we'll see DENAP. So again, now we need to set up a code. So we say this will be PW code. We will select a corresponding plugin, which is Quantum Espresso PW. Yes, here. Then we provide description, which we won't provide. We put some random path. And then we click on setup code. And this is done. So now we come back to our place where we wanted to run the simulation. Sorry. Just take one example that all the rest appears. And then we already have, so we click on refresh button, and then we have PW addendum. So that's all kind of provided in a semi-automated way. Now, so what I was talking so far was kind of a toy example. You can get an account on IdleUp, you can do your simulation, but then this is only not for playing with Quantum Espresso. People at Tampa, where we were working where I was working before, have developed a set of tools that help them to actually help them to simplify their daily scientific life. Here I just showing a video, which is actually a tool that allows you to plot projected density of states. So you had a list of calculations you have done before. You click on one, and then you select the atoms that you want to on which you want to project the density of states. Then you click on plot button here, and then the projected density of states will appear just here. So for those of you who have an experience with projected density of states, you know how tedious it is to actually compute them and to plot them. And here with such an application, it's just one click. Now, let's continue with the examples from EMPA. And here is really the case where IdleUp becomes important. Because they have two kind of subgroup of the same group. One is experimental and one is simulation subunit. And some while ago, like before IdleUp Air, the typical question was, some while ago we discussed ribbons ABC. Do you have a band structure for that? The question can be about a band structure that was computed 1 year ago, and then the question is meaningless because even though you have done this calculation, you probably don't know where they are. And then, of course, the second question: how does it take long to have the band structure of this particular material? So, and now things have changed quite a bit. Here's the email of group leader that directly writes to experimental PhD student, and he says, I'm discussing priority, and he knows already that they have a list of band structures computed. So the person who doesn't know how to do simulation can go to IdleUp, can look the structures, and knows what data are already provided. And then he knows the status of the available calculation and implicitly expecting this will be fast, because he says, could this be done quickly? And again, I stress here the fact that the email is not to the computational scientist, he is in CC, but to experimental students. And now, quite quickly, the experimental student replies that he can run AiiDA DFT calculation. So he feels comfortable to do it, and then basically, as you can see, no support needed. So this is to stress the fact that in such an environment, in such a heterogeneous environment where experimentalists work with theoreticians, quite often you do routine work, like computing the band structure. And of course, you don't want to spend your time on doing this over and over again. And for those kind of purposes, it is quite nice to have an application that basically does it for you. Now, there is an obvious question: how to make your own application? Well, as you saw already, there was this help button that you can click on, and then you will be redirected to a wiki page that explains all of this for you. So there are two ways. One, if quick start, you can use a cookie cutter for that. You just say cookie cutter, and then you provide the URL, and then the app will be created. It will ask you a couple of questions, and then it will be created. Otherwise, you can just follow kind of old strategy. You create a folder, you put some files inside, and then it will become an application. Here again, there is a video, but probably let's do it. In a real demo. So again, we go to the terminal. Is it visible, or should I make it? Can you increase the font? Let's try. The font I cannot really increase.
Oh,
Yeah.
Better?
Yeah.
Okay, so the first thing you need to do is to go into apps folder. By the way, just that you know, the app is not yet there, so I can update the home page. You can see that there is no such an application here. So there is the first application is the IdleUp widget, and the application we're about to create will appear first on the list. Now, we're inside apps folder, so we do cookie cutter. I've done it before, so I don't need to type it again. And then it says there is a cookie cutter recipe was downloaded before, so should we use it? We say yes. And then it will ask you a couple of standard questions. What is the application name? We put app, new app, or whatever. It's again app title, new app. Short description, we don't provide a description. GitHub user, I put my username on GitHub. Then repository name, we keep default. Contact email, again. Version, author, year, and all this. So, as you can see, there was just a couple of questions that you had to answer, and now the application will appear on the screen. So I will just update the start page. And here we have a new app. But it says that there is no Git repository. And actually, IdleUp requires you to have a Git repository inside, initialized in the app folder. So we will do that. We'll just go inside IdleUp, new app. We'll do git init. And then we update it here. And then there will be another complaint about no remote URL. But in order to make it happen, you actually need to register your application in the IdleUp registry, which we won't do now. And the last thing that I probably show on the video here is the App Store. App Store is an app store that allows you to look for the applications that are already provided in the app registry. So you have a list of applications, and if you want, you can show only installed ones. Here we have only installed. Then you can filter them by category. So you can choose the category, apply a filter, and you will see only the applications that are belong to a specific category, tutorials or quantum. Then we can clear the filter. We can remove show only installed. So it provides quite a bit of flexibility. And of course, we would like to improve it a little bit more. We would like to provide a placeholder where you put the app name and it will be looked for you. And now the application that I just installed appears the first on the App Store. And of course, you can click on Manage App button. You can go to app homepage. You can select you can see the list of authors, description, and you can select the particular version of this application. So so far so good. We are approaching already the end of my presentation. I just wanted to emphasize the fact that all this functionality is not only provided as in a cloud, but you can also download a so-called Quantum Mobile Virtual Machine that has all of this installed. It is running on Ubuntu 18.04. It has AiiDA and IdleUp. It has a couple of codes, and it's by itself it's quite configurable. So if you would like to do a tutorial, you can customize it for your needs. So you remove all the codes that you don't want to use. You keep only ones that you want to use, and then you distribute it among your students. So what we actually did for this particular tutorial. And then a few words about future plans. IdleUp will be soon offered for larger community because for the moment we open it only for Marvel. And the reason that before it was not scalable. And now we'll move it to Kubernetes, which automatically scales the amount of resources with the number of users that are logged in. We are already in the process of migration to AiiDA 1.0, and the people who will learn how to use IdleUp today will actually use the migrated version. And we have some application in preparation, like CP2K workflows, workflow to study gas absorption. And of course, since it is quite a new service, we are quite open for suggestion. And if you have anything you would like to recommend or you would like to have on IdleUp, please let us know. So as a conclusion, I would like to emphasize that AiiDA is a powerful tool. It allows you to run workflows. The AiiDA daemon helps you with automation. AiiDA graph is the map to the data jungle. So with IdleUp, you can actually know where your data coming from, and you can query them. And your calculations are ready for open science. If you want to publish them, it's just enough to export your AiiDA database and put it somewhere, for example, Materials Cloud. And here, about IdleUp, so you saw that writing an application is quite a straightforward task. You just need to know Python. You can run it wherever you like on your machine. If you would like to have your machine and your setup, you can run it on Quantum Mobile, where we provide a machine with everything already pre-installed, and you can have an IdleUp account where everything is provided by us. And plan for the group work. So today, it was already kind of stressed out a couple of times that we'll have a group work up in this afternoon. So the people who want to learn how to create IdleUp application will basically follow this plan. So we will learn how to use Jupyter if you don't know yet. Then we'll learn how to use IdleUp. And then we'll learn how to, what are the technologies behind IdleUp, like what's IdleUp meta package, Docker stack, widgets-based, and registry. And then we'll learn how to create your own IdleUp application. With this, I would like to acknowledge the support agencies, and I would like to acknowledge the people who contributed all of these things, including AiiDA, IdleUp, and Materials Cloud. And I would like to thank you all for your attention. And please, if you would like to have an account, just write an email here, and we'll create it for you today. Thank you very much.
Are there any questions? I can start with one. So, would you be willing to give a quick demo of the code of one of these apps?
Oh, sure.
I think one of the most important facts about the IdleUp is, or one of the most important decisions you have to make is like, how much effort is it to write such an app, right? And so all of these apps are Jupyter notebooks, and plus one start file that defines what you see here, just so a list of links. And the idea of the IdleUp is really that writing app is so simple that it makes sense to write one for your specific use case. The idea is not that we'll provide the most general app possible that will work in every possible use case, but the group at EMPA, they write very specific apps for their use case, and because it's so easy to do, they still get a benefit from it because the experimentalist starts using them, and they have to do less work.
Yeah, so yeah, thanks for this nice suggestion. Here we have this new app that I just created, you saw it. And here we have an example notebook. So let's just go inside and see how it looks like. So this example application is just is able to upload and store the structure in the database. So you can see that it's functional. You select the structure, it works. You can store it in AiiDA, so no problem. So how much line do you think it takes to write such an application? Well, in reality, it takes 3 lines because we provide a library that has this structure upload widget, and then you basically create it and you display it. So we can just run it, and you see it's there. So, and of course, we need some machinery to deal with codes. And so most of these are already provided inside IdleUp, which is base repository. So let's just create a structure computer selection widget. So we do code drop down, we import it, and then we say code. Sorry, I forgot one thing. That's very important. I need to say what partial it expects. So it should be quantum espresso .pw. Didn't I do any mistake?
Let's see.
Let's see. Now it works. Oh, I was scared. Now we do display code. And here we have this widget that we were using in calculation example. So again, you have a list of quantum espresso codes that are configured on IdleUp, on your IdleUp instance. You can set up a new code, and all this machinery is provided basically for you to you for free. Yeah.
Thank you, Sasha.